This is the Standard Gauge Railway, or the SGR, a nearly 500-kilometre stretch of elevated track cutting through the heart of East Africa at 120 kilometres per hour. It connects the port city of Mombasa on the Indian Ocean to the capital Nairobi, in what was supposed to be the centrepiece of Kenya's modernisation story. What actually happened is something far more complicated. China invested over $3.5 billion to build this railway in just 3 years, faster than virtually any comparable project in the world. However, it's a financial arrangement so consequential that it may define Kenya's future for generations. This is the full story of how China built a railway under the African sky and what it cost. There are few things that change the shape of a country quite like a railway. Roads take you from one place to another. A railway restructures an economy, shifts where cities grow, decides which ports matter and which ones don't. And so, when a government decides to build one, the stakes are never just logistical. They are political, they are generational, and in Kenya's case, they became something close to existential. To understand why this project happened at all, you have to go back to the colonial-era railway that the SGR was built to replace. The original line running the same Mombasa to Nairobi corridor was constructed by the British starting in 1896 and was built on a narrow-gauge track. It was also immediately nicknamed the Lunatic Express by critics back in London, who couldn't believe anyone would spend that kind of money to lay track across what was then unfamiliar and challenging terrain. Dozens of workers were killed by lions during construction. Hundreds more died from disease. The project went massively over budget. And yet the British built it anyway because whoever controls the movement of goods controls the territory. That logic has never really changed. By the early 2000s, the old narrow-gauge line was in serious decline. It had never been modernised to any meaningful degree, and by then, the vast majority of freight between Mombasa and Nairobi was moving by road instead, through a trucking industry that had grown up precisely because the railway couldn't be relied upon. The highway between the two cities was chronically congested, perpetually damaged by the weight of heavy lorries, and the situation was getting worse every year. The port of Mombasa, already operating under significant pressure as one of the most important deep-water facilities in the entire region, was struggling to push cargo inland fast enough. Containers were backing up, costs were rising. Something had to change. Kenya's government made the decision to build a new standard gauge railway, and they wanted it done quickly. The problem, as with almost every major infrastructure project in sub-Saharan Africa, was money. The Kenyan government didn't have it. Western lenders weren't offering it at terms the government could accept. And then China stepped in. The financing came through China Exim Bank. The construction contract went to China Road and Bridge Corporation. The terms of the deal, as we'll get into later, were not straightforward, but the initial pitch was simple. China would lend Kenya the money, Chinese companies would build the railway, and the result would be modern infrastructure that the country could never have afforded on its own timeline. In 2014, the government announced the project would be complete in time for Kenya's 50th anniversary of independence, which was 3 years away. Most independent analysts called that schedule impossible. They were wrong. To understand how you build 480 kilometers of elevated railway in 3 years, you need to understand what China brought to the project that nobody else could have. The answer is a machine. Specifically, a bridge-laying machine of a type that most countries in the world have never used in the field at this scale. Imagine a steel frame nearly 100 meters long, weighing close to 500 tons, straddling the construction site overhead. This device doesn't require a crew to hoist individual beams into place one at a time. It picks up precast concrete sections on its own, runs them along its own frame, and sets them onto the next column without stopping. While engineers in other countries were writing environmental assessments, this machine was laying track. In a single day, under good conditions, the route advanced by hundreds of meters. The key to that speed is what the Chinese engineers had done long before the machine ever arrived on site. Every concrete section placed by the bridge-laying machine was manufactured off-site to exact specifications in a controlled environment. That meant the machine was never waiting for material to cure or be prepared. It arrived, it was placed, and the machine moved on. The rhythm of it was almost mechanical in the literal sense, repetitive, relentless, and deeply impressive to anyone who watched it happen. But the pace came with risk, and the engineers knew it. Concrete in the equatorial climate of Kenya behaves differently than it does in a Chinese factory. Temperatures on the surface can reach 70 degrees Celsius during the day. The same material that performs predictably at moderate temperatures can crack, expand, or fail when the heat cycles through extremes like that, day after day, for decades. So Chinese chemists developed a specialized concrete mix adapted to those conditions, and the water used to prepare it had to be purified using a separate process designed specifically to prevent dissolved salts from corroding the steel reinforcement from within over time. 10, 20 years down the line, the engineers were calculating for that. The same obsession with long-term precision ran through every element of the track itself. Standard steel rails deform under prolonged heat. For a high-speed line in an equatorial environment, that's not a theoretical problem, it's an operational one. So the rails were tempered using a technology that stabilized the metal against thermal expansion. A deviation of a single centimeter at 120 kilometers per hour isn't a minor inconvenience, it's a catastrophe. And yet the ground beneath all of this was arguably the hardest problem of all. Kenya is geologically complex in a way that surprises people who haven't worked there. In the rainy season, certain soils essentially liquefy, not all the way, but enough that heavy machinery sinks and embankments wash out, and what was perfectly level yesterday has shifted by morning. In the dry season, the same soils crack deeply enough to swallow a vehicle tire. Laying a precision, high-speed track across that kind of surface requires an entirely different approach than standard railway construction. The solution was what the engineers called layered cake construction. A trench was dug to roughly head height. Then it was filled in stages with alternating layers of different grades of gravel and sand, separated by sheets of geotextile, a synthetic fabric that acts as a membrane between layers, preventing them from mixing under load or over time. This technique stabilizes the subgrade in a way that ordinary compaction alone can't achieve. But it's slow, and it has to be done right. A shortcut in this layer would compromise everything built above it. Then there was the drainage. This is the detail that tends to get lost in the broader story, but the project's engineers will tell you it consumed as much thought as almost anything else. Tropical rainfall in Kenya doesn't arrive gently. When the rains come, they arrive in volumes that can overwhelm conventional drainage within minutes. If water gets under a railway embankment, it undermines the structure from below. A loaded freight train weighing 2,000 tons doesn't leave much margin for error in the foundations beneath it. So thousands of kilometers of concrete channels and drainage conduits were built alongside the tracks. engineered to move every drop of water away from the embankment before it could accumulate. The drainage system alone costs more than some entire railway projects on the continent. And then there were the termites. Termites are the unsung enemy of any large-scale construction project in East Africa. They are extraordinarily efficient at destroying insulation on electrical cables, which in a modern railway control system creates the potential for short circuits across the entire network. Chinese chemists developed a specialized compound for the concrete and plastic components most vulnerable to termite damage. A repellent built directly into the material rather than applied as a coating that would eventually wear away. It's the kind of detail that sounds almost trivial against the backdrop of a billion-dollar infrastructure project, but without it, the system could have been compromised within a year of opening. Perhaps the most visually dramatic engineering decision of the entire project was also its most expensive. The 120-kilometer elevated viaduct section running through Kenya's national parks. National parks present a different kind of obstacle, one that's not physical so much as legal and political. Kenya's wildlife reserves are internationally protected zones. The Tsavo National Park alone is one of the largest in Africa, covering an area larger than Wales, and the railway corridor passes directly through it. Building at ground level would have fragmented migration routes, created physical barriers for wildlife, and almost certainly triggered the kind of international environmental opposition that can hold a project in court for years. So the engineers went up instead. For 120 kilometers, the railway runs on a viaduct at the height of a 5-story building, elevated entirely above the ground, so that the savanna beneath it continues undisturbed. Elephants, lions, and giraffes move below the track without disruption. The ancient migration routes of wildlife that have been using this corridor for thousands of years remain intact. It is genuinely one of the more remarkable feats of environmental engineering on the continent, and it was also brutally expensive. The challenge of building elevated in that environment wasn't just the height, it was what lies beneath the surface. Much of the terrain through the parks is swampland or is composed of soils with very low bearing capacity. Every column supporting the viaduct had to be drilled down to solid bedrock, sometimes 30 meters below the surface. 30 meters is the height of a 10-story building, straight down through unstable soil, before you even begin building upward. There were thousands of these columns. Each one required hundreds of tons of concrete and high-strength steel. Each one had to be placed precisely, because the tolerances on an elevated high-speed structure leave no room for columns that are even fractionally out of alignment. At one point during construction, the demand for concrete exceeded what Kenya's entire cement industry could supply. The country's factories were running at full capacity and still couldn't produce enough material to keep the machines moving. A conventional project would have had to slow down, wait for supply chains to recover, and accept the delay. The Chinese contractors did something different. Within 48 hours of identifying the supply gap, they deployed mobile factories, temporary manufacturing plants relocated along with the construction front, producing concrete sleepers and structural beams directly on site as needed. Each of these facilities was operational within 14 days of being established. They produced everything from sleepers to the enormous 50-ton beams used in the elevated sections, and they were closed sites, accessible only to project personnel. No outside suppliers, no local subcontractors, no external visibility into what was happening inside. That self-contained quality of the construction operation is worth pausing on, because it tells you something important about how this project was structured and who ultimately benefited from it. More than 25,000 people worked on the SGR at its peak. Of those, the Chinese specialists occupied the management, engineering, and technical roles. Kenyan workers were employed in large numbers, but mostly in laboring positions. The discipline enforced on site was unlike anything local workers had encountered. Fines for lateness were measured in minutes, 3 rotating shifts around the clock, and an insistence on precision that led to constant friction between Chinese foremen and Kenyan staff. The speed came from that discipline, but also created significant resentment. And then there is the financial architecture that made all of this possible. The loan from China Exim Bank totaled roughly $4 billion, which was approximately 10% of Kenya's entire gross domestic product. The interest rate was not the kind offered to countries with strong credit ratings. And the collateral written into the contract was, to put it plainly, crazy. The port of Mombasa, Kenya's only major deep-water port, the gateway through which almost all of the country's food imports and fuel pass, was placed as security against the debt. If Kenya were to default, the terms of the contract gave the creditor rights over the management of that port. Think about what that means in practical terms. Kenya imports the majority of its refined fuel by sea. It imports a significant portion of its food. The machinery that keeps the country's manufacturing sector running comes through Mombasa. The exports that generate foreign exchange like tea, coffee, and cut flowers leave through Mombasa. An external entity gaining operational control of that facility would effectively control the flow of goods in and out of the country. This is not a hypothetical risk buried in fine print that nobody read. It is a documented clause in an agreement signed by the Kenyan government. When the railway opened in 2017, it was an event of genuine national celebration. The stations were radiant and modern. The trains ran on schedule. The journey from Mombasa to Nairobi, which had taken between 8 and 12 hours by road depending on traffic, now took approximately 4.5 hours by rail. Passengers travelling in standard class paid a fraction of what the equivalent bus journey cost. By any measure of user experience, the SGR delivered exactly what had been promised. The freight operation was more complicated. The railway was projected to capture a significant share of the cargo moving between Mombasa and Nairobi. And in the first years, there was genuine movement in that direction. But the economics were stubborn. Trains run most efficiently when they carry loads in both directions. Goods coming in from the port and manufactured exports going out from the interior. The fundamental problem is that Kenya doesn't have a manufacturing sector large enough to fill freight wagons traveling back toward the coast. The outbound trains were running near capacity. The return journeys were largely empty. And an empty freight wagon doesn't pay for itself. It accumulates losses. To address the deficit, the government took a step that sent shockwaves through the community of workers. A decree was issued mandating that certain categories of cargo, particularly imports arriving at the port destined for Nairobi, could only be moved by rail. Truck drivers, who had been running the Mombasa-Nairobi corridor for years, sometimes for decades, found overnight that their business was no longer legal. The roadside economy that had grown up along the highway over generations, the fuel stops, the repair workshops, the restaurants, the small guest houses began to collapse within months. Entire towns that existed because lorries needed to stop and drivers needed to eat became, in the words of people who watched it happen, ghost towns. This is the cost that doesn't appear in the press releases, not the $4 billion, the destroyed livelihoods of thousands of ordinary Kenyans who had built something real along that highway. and who lost it, not because of market forces, but because of a government decree issued to protect the viability of a railway that was losing money. And even with forced freight volumes, the railway has continued to operate at a loss. Independent estimates suggest that the fare a passenger ticket would need to cost for the line to break even without subsidies is roughly 10 times the current price. That gap is filled with borrowed money. Every journey today is, in a very literal sense, debt that accumulates and will eventually be owed by people who haven't yet been born. There is one more dimension to this story. The SGR is not simply a physical railway. It is a technological system built entirely on Chinese software, Chinese communications protocols, Chinese safety architecture, and Chinese control systems. Kenyan engineers were trained to operate the railway at a functional level. They can monitor a sensor, they can respond to an alert, and they can follow a procedure. But they were not given access to the underlying code, the switches, the signaling, the communications network, the safety, interlocks. All of it runs on systems whose source code lives in China and is not available to Kenya. Spare parts must be sourced from Chinese suppliers because the connectors and protocols are proprietary. You cannot buy a compatible component from a European or American manufacturer. The system simply won't accept it. This is what engineers who study infrastructure dependency call a technology trap. It's not accidental. A country that cannot maintain its own critical infrastructure without ongoing technical support from the company that built it is a country that has traded one kind of dependency for another. And the leverage this creates is not theoretical. If Kenya were to take a political position that conflicted with Chinese interests if it were to attempt to renegotiate the loan terms, or if it were to seek alternative financing from a competitor, the system could, in principle, be shut down remotely. The thousands of cameras at the stations were equipped with facial recognition technology that transmitted data to servers. Local authorities have only partial access to that data. The rest flows outward. China has now signaled its intention to extend the SGR corridor beyond Kenya through Uganda into Rwanda and eventually into South Sudan. The logic is straightforward. A rail network connecting East Africa's landlocked interior to the coast creates an infrastructure through which the movement of goods and the extraction of natural resources can be managed and monitored. Rare earth metals, minerals critical to modern electronics manufacturing, agricultural commodities, all of it would flow along this corridor. And whoever built the corridor, whoever maintains its software, whoever holds the debt on its construction, exercises a form of influence that no amount of diplomatic language can fully obscure. The SGR is in many ways a genuine engineering marvel. The bridge-laying machine, mobile concrete factories, the elevated viaduct over the national parks, anti-termite compounds, thermal stabilized rails, and the drainage systems engineered for tropical extremes are remarkable. China demonstrated something real, that infrastructure, which wealthy countries assume requires decades of planning and unlimited budgets, can, under the right conditions, be built in 3 years. That fact stands on its own, but a railway is not an abstraction. It is built somewhere by someone on terms that someone negotiated. And the terms on which the SGR was built are terms that Kenya will be managing for a very long time. The trains run beautifully through the savannah at 120 kilometers per hour. The stations gleam. The journey that used to take most of a day now takes an afternoon. None of that is nothing. But somewhere in Mombasa, in the fine print of a contract that was classified for years, is the clause about the port And somewhere in Nairobi, there are thousands of truck drivers who lost their livelihoods not to market forces but to a decree. And in the control room of a railway that a country borrowed the equivalent of 10% of its GDP to build, Kenyan engineers sit in front of systems they are not permitted to access. Progress is never free. In Kenya's case, the question of who ultimately paid for this one and who is still paying and who will continue to pay long after the last Chinese contractor has gone home is real, as is the debt and the leverage. The empty stations after dark are real, and the trains will keep running on time and on schedule through the savannah and over the national parks and into the future that Kenya signed for. Whether or not it fully understood the terms is another question.